Next up, from Condor, please welcome Mitch Negus. The clicker does work.
It does. Excellent. Which, assume up is forward.
I think it might be the opposite.
There we go. Sorry. All right. My name is Mitch Negus, and I'm thrilled to be representing the team of Condor here. All right. So, if you could tap into a $50 billion market while solving one of humanity's most daunting challenges, would you miss your chance? I certainly wouldn't. And so that's why here at Condor we're tackling the issue of used nuclear fuel. So today, used nuclear fuel is stored in dry casks like this one. They're solid concrete and are a couple times the size of your average adult, and they weigh anywhere from 80 to 200 tons. So you're not moving these things very easily. Inside of that dry cask, there's an internal canister made of metal, and that is sealed to prevent the highly radioactive nuclear waste from getting out of the cask. Now, it's estimated that there will be 100,000 metric tons of used fuel provided or produced in the United States from all of the United States' current nuclear reactors, and it's estimated that each kilogram of that nuclear waste will cost $500 to be disposed. We've done the math for you, and that's the $50 billion that we were talking about. Now, the United States government created the Nuclear Waste Fund in 1982, and the utilities have paid into that. But currently, that waste fund stands at only $22.5 billion, and if you factor in the projected maximum of that waste fund, it only gets to $32 billion. That's still almost $20 billion shy of the $50 billion that we're projecting. And so that's where Condor comes in. Condor takes two well-known, understood topics, reprocessed nuclear waste and advanced reactors, and combines them together in a single loop and on a mobile platform. This mobile platform can be brought to nuclear power plants, and the nuclear waste can be input into the cycle. Commodities, such as medical isotopes, can be taken out, and the remaining product from the reprocessing fed into the advanced fast reactor cycle, which is then output as a vitrified waste product, which is much easier to deal with. So, DOE, pay attention. We're talking to you. You're the ones who have been enlisted to take care of this, and so we're marketing our product at you. So, we're saying that we're better than all of the existing technologies, whether that's current disposal in a site like Yucca Mountain underground, or reprocessing. So, moving forward. On-site management, we have that covered. You don't have to move those 200-ton casks anywhere else. We're coming to you. Next, the amount of time that it takes to neutralize the waste in our combined cycle is significantly less. Here, you can see in the graph, direct disposal takes almost 10 times more years to reduce waste and neutralize as current reprocessing and advanced reactor technologies, and we're even taking it a step further in our proposed plan down to on the order of 330 years as opposed to hundreds of thousands. Now, following that a little further, you can then extrapolate and say that because our waste is less radiotoxic, in the long term, you don't necessarily need a deep geological repository like Yucca Mountain. Something that has more relaxed constraints would be more than acceptable. Also, non-proliferation concerns. Our fuel cycle research and development plan will include methods to make sure that when we separate the products, we're not allowing the weaponizable products to leave our system. They will be contained. And finally, as I mentioned earlier, we will be creating marketable products such as medical isotopes or noble metals. All right, so as you can see, we're still well out on top. All right, so how are we going to do this? The team is a series of us 5 engineers. Sasan's missing, unfortunately, but we have a background in a whole variety of engineering disciplines. We have Adria with a degree in chemical engineering, Sasan, background in electrical engineering, Shirly, nuclear engineering, but specializing in operations and maintenance, Efstathios, fuel cycle and waste disposal, and myself, computational modeling and simulation. So real quick, how we're going to do this. Phase 1, the next 3 years, we're looking to demonstrate our technology and ally with a compatible reactor technology, as well as seeking out a GAIN partnership for what it would be about 5 million. That moves on to a prototype, valued at 100 million, where we exhibit our combined cycle, contract and initial unit. We're looking at Illinois because they have the most metric tons of uranium. And then move that one step further to manufacture the systems and contract additional units at production scale. We're looking for 5 million. Half of that is facilities and equipment, and the last batch is for operational expenditures such as materials, legal counsel, and staff. There you go.
Well, you get to
Do I assume some sort of fast spectrum reactor here to eat
exactly.
spent fuel rods, right? Yeah. And 5 million will get you not very far in the certification to operate such a thing. So what comes after your initial study?
Sorry, so I guess I didn't get a chance to explain that on the slide. So the 5 million is our initial proposal for research and development. Then we'll be fundraising additionally once we have our proof of concept for the 100 million in phase 2, and then.
And typically a 10-year certification process in the U.S.?
We'll be working with utilities. That's sort of why we focused on Illinois, as where we're moving our operations to, so we can gather help of utilities and pressuring
Great.
government.
But you're going to do that. The guys in Illinois are good at this. So another thing, these spent fuel rods are, as you know, are only 4 or 5% used.
Yes.
So there's an enormous amount of energy to consume, right?
Absolutely.
And your mobile thing is not going to move very often.
No, that is correct.
Yeah. So I think the cartoon on wheels is a little exaggerated.
That's correct. And
I'll just point that out.
So in reality, you could maybe track this in on a fleet of trucks. We're not necessarily limiting ourselves, but
Yeah, skid-mounted, modular kind of thing, right?
absolutely.
Okay.
I heard you talk about the 50 billion opportunity. I missed how much you think it will cost to do the processing with your technology.
As operational once we get going? Or
Yeah, at scale, assuming that you're able to get up to scale.
That was actually in phase 3. I
Okay.
Into that. That
Yeah.
was 1 billion. So
Okay.
figure out the 20 billion.
Yeah.
1 billion. So I was getting that. Over 10 billion.
Thank you.
The processing is very costly operation, so we don't expect that just by reprocessing that we will lower the expenses and we will have a gain from that. But we will have profit from the products of reprocessing, from the medical isotopes, from extraction of rare noble metals of spent fuel, from fueling fast breeder reactors, and this is how we are going to make the growth.
Got it. Thank you.
Thank you, guys.
How small do you envision you can make this model? Do you have any idea?
The prototype?
No. You got a container here, a 40-foot container?
Maybe we'll discuss with you after.
Good answer.
Okay.